And recording today is 12/3/18. Okay, so one of the good news is about geometry is geometry is pretty easy. You guys have been doing geometry probably since like preschool, Sesame Street, right? Yeah, it's super easy. So we already should know what a parallelogram is, but if we look at a parallelogram, let's just look at its definition. So the definition of a parallelogram has to be the fact that you have a quadrilateral, which means four-sided figure, okay? Quadrilateral means four-sided figure. So you have a quadrilateral with two sets of opposite parallel sides. Okay? That's the definition. Okay? It's a quadrilateral with two sets of opposite parallel sides. Okay? So then what you'll see is you'll see these little markings. See these little markings? When you see these little markings, you'll know it's trying to say that's parallel to that and that's parallel to that. Okay? And so if you see those little markings, you automatically know right off the bat that it is parallel. Okay? So there's a lot of things that happen with parallelograms. This is the definition, but there are things called its characteristics. We want to go through the characteristics right now. Okay, so first of all, what do we know about the characteristics? Well, we do know that if we looked at, in fact, it even looks like it. Angle A looks congruent to angle C, doesn't it? And it looks like angle B is congruent to angle D. And sure enough, in a parallelogram, we know that opposite angles are congruent. So, for instance, if this angle were 70 degrees, that angle would be 70 degrees, right? We know if this angle is 130, this angle would have to be 130, okay? Opposite angles are always going to be equal in a parallelogram. You probably knew that. Okay, these are pretty easy ones. Okay, now it talks about the lengths. We also know that opposite sides are congruent. Okay, so I know that this side is equal to this side in length, and this side's equal to this side in length. That's pretty easy, right? And we already knew that. I mean, these are just characteristics we already knew. Okay. Now, there's some other things that we need to know, and that is this. I put in, on purpose, the 70 and the 130, okay? Those two add up to 180, don't they? Put the 70 and the 130.
No, 200.
That's right. It is 200. 110. Thank you. 110. My bad. It's Monday morning for me, too. Thank you. Okay? So, we are going to say, now that I got it fixed, thanks, Annie, that we're going to say that adjacent angles are supplementary. Now, supplementary is a word we haven't talked about, but supplementary means two angles that add up to 180 degrees. So we're going to say that adjacent angles are supplementary, meaning they add up to 180 degrees. So the word supplementary is two angles that add up to 180, okay? There's the word complementary. I don't know if you've heard that word, but it's two angles that add up to 90, okay? So we know that these two angles add up to 180, or these two angles add up to 180, or these two angles add up to 180, or these two angles add up to 180. So far, so good? Okay. All right, let's talk about the diagonals, okay? So let's go to the next page, okay? So what do we know about diagonals, okay? Well, if I look at these diagonals, okay, the diagonals are the lines that go through, right? So the diagonals don't look equal, do they? But what they do is they cut each other in half. This diagonal cuts this diagonal. So what we see is that BD bisects AC. So diagonals bisect each other. So we'll say diagonals bisect each other. So if that happens, they cut each other in half. The word bisect means cut in half. So I can say that this length of BE is equal to this length of ED. So we'll say that in this case, BE is congruent to ED, and this length AE is congruent to this length EC. So we can say that AE is congruent to EC. All right? Does that seem pretty easy? So those are the properties or the characteristics. And tomorrow we're going to have you guys, I'm going to have you make posters on this so you can write all the characteristics down, because there's more. There's more. We're going to keep learning more about it. Okay? So let's turn the page and do some math. Okay? So let's go all the way to page 232. So you're going to see questions that are going to be more like your homework. Okay? Let's go to page 232. Thank you for being quiet. So much easier for everybody to learn now that's quiet, right? So let's take a look at it. So it says it's a parallelogram, so here's what I know. Just by its definition, I know that opposite sides are equal, right? So if I have to find x and y, I really don't want to do 4x and y, because if I set those equal, then it wouldn't tell me much, right? But I could figure out what x is through these two, right? I could set this side equal to this side. So I go straight to x plus 18 and set that equal to 3x minus 2, right? Set them equal and just solve for x. And that would give me the value of x. Okay, so let's do that. Let's go minus x. I'll have an 18 equals a 2x minus 2, right? Plus 2 on both sides, I'll have 20 equals 2x, right? Divide by 2 and I get x equals 10. All right? So that gives me the value of x, but if I want the value of y, I'm going to have to go back, right? So let's take this 10, let's plug it right in here, okay? So 4 times 10 is 40, and since these two sides are equal, if this side's 40, then y has to equal 40. Okay, thumbs up. Okay, let's take a look at number 2. Okay, so number 2, one of the characteristics we learned is that opposite angles are equal, right? So if I want to find the value of x, I can set these two equal. So, okay, let's go to a 4x minus 37 and set that equal to 49, right? These two opposite angles are equal, so I just need to solve for the value of x. Plus 37, I don't know, 49, give me a second, 49 plus 37 is 86, so I've got 4x equals 86. Divide by 4, and I can answer 21.5. Okay, so that's the value of x. So if I know that, then I can take and plug that in over here. So let's see, I'm going to take that 21.5 and put it right there, right? All right, so what is, I'll do it up here, what is 4 times 21.5 minus 3? I'm just going to do that work up here. Use my calculator. I'm going to go times 4, and I'm going to subtract 3. I didn't like that. Go to it. Okay, subtract 3. So I get an answer of 83. So this side is 83. So if I want to find y, I'll take these two and set them equal. So I'll say, all right, 83 is equal to y over 5. I'm going to multiply by 5. Does that make sense? Why I'm going to multiply by 5? Because I have to undo the divide by 5. So I'll multiply by 5, cross multiply. So it's 83 divided by or times 5. So y is going to be 415 degrees. Okay. So far, so good. Okay. Let me do 3, and then we'll solve this one. We'll be done. All right. Okay. 3 diagonals. What do we know about diagonals? They're equal to each other, right? They're equal. So this diagonal is equal to this one, and this diagonal here is equal to this one. I'm not going to tackle these. Well, I could get the y's. Let's get the x's and the y's, okay? So let's get the x's first. I'll just go 2x plus 10 equals 4x minus 2, right? Oh, minus 2x minus 2x. I've got a 10 equals a 2x minus 2, right? Am I going too fast? Okay, plus 2, I got a 12 equals a 2x. Divide by 2x is 6. Easy. Okay? And then, if I want to find y, I'll do the same thing. These two diagonals are equal. We'll go 5y minus 16 equals 3y, right? Go minus 5y minus 5y of a negative 16 equals a negative 2y. Divide by negative 2 and I get y equals 8. Okay? What do you think? Pretty easy? I mean, this is stuff you should know. This stuff you probably learned, like you guys said, in 6th grade you learned this stuff. I'm pretty sure you did, right? Okay, number 4 through 10. All right, this is easy. Okay, now, all right, first of all, another thing that happens is this whole angle here is 68. Then this angle right here is also 68. Okay, does that make sense? That's 68. That's 68, right? Okay, if this is 59 degrees here, right, then this angle here is 59. Just that part of it, 59, 59, okay? Because those lines are parallel, right? This is 20.7, that's 20.7, right? If this is 20, this side's 26, then this side's got to be 26. If this side's 24, then this side's 24. Pretty easy so far? Oh, if this diagonal's 14, this is 14. Okay, what am I missing? Anything? I think I got it all pretty much. So, we can just fill it all out. PO, let's see. PO is 14. Got that. OQ. OQ, where's O? OQ is right here, is 14. Oh, these are easy. NO, where's N? NO is 20.7. That was given to me. Oh no, I got to double that. NO is 26. My bad. PQ. PQ. Here's Q. Where's P? PQ is 20.7. Angle PMN. P. Where is it? PMN. Okay. How do we get this full angle here? Anybody know how to get this full angle here? I do. Huh? How about if I add these? How about I add these? Let's see. What if I add these? What's 68 plus 68? 134, 36, 136, right? 136. Okay. Now, what if I took 360 from that and divided up here and here, okay? So I know these two together make 136. What if I subtract from a 360, right? Let's see, 360 minus that. Oh, hold on. 360 minus that. 224. And then what if I divide that by 2? Should divide it up, right? Divide by 2. Okay, so then I know this full angle is 112, which means that full angle is 112. See how I did that one more time? Okay? These two, well, the whole thing equals 360. Okay? You agree with that? The whole thing equals 360. So that and that, 68 and 68, is 136, right? So these two occupied 136. So I said, okay, what's left over? So I subtract from 360, 224. That's what's left over. And divide it by 2, half and half. So then I can get that angle there. Let's see, 112 minus 59 gives me 53. So that's got to be 53, and that's 53, and then we can fill out the rest. Okay, PMN. PMN is 112. NOQ. N, where's O? N, O, Q is 53. OPM. OPM is 68. Almost got it. NMON. M. Gotta find M. O. N. M. Where's O? There we go. 59. I think I got them all right. Okay. Easy? Yes. Did I make a mistake?
Number 4, PO. Isn't that 24? Yeah.
Probably. Yeah. P to O. 24. Yeah. N O P. Oh, 112. No, N O P is 112, right? N O P is 112. Okay, thanks, you guys. Okay, now.